Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. We are team from University Tun Hussein on Malaysia. Our product name is Fibreglass Panel Board. Before we start, let me introduce first our group member. First, TS Dr. Nurhayati binti Ngadiman. Second, Prof. Madia TS Masiri Kamin. Third, Dr. Khairi bin Supar. Fourth, Muhammad Hafiq Hafifi bin Azman. Fifth, Muhammad Lokman Hakim bin Badrul Hisham. And me, Siti Syahrina binti Misran. We would like to share about Fibreglass panel board. The E-glass is the most common reinforcement material used in civil and industrial structure. They are also called glass fiber reinforced polyester, carbon fiber reinforced polyester, natural fiber reinforced polyester, and fiber reinforced composite. E-glass type fiber was chosen and used in making the Fibreglass panel board. We use E-glass because the price is low. The Fibreglass panel board was produced by layering the Fibreglass made. We have two main objectives. First is produce a medium size of Fibreglass panel board. Second, properties of Fibreglass panel board: higher strength, water resistant, more durable, and have aesthetic value. For novelty and inventiveness, first, fully Fibreglass without combine any material, and the second one is we use a layering technique to produce Fibreglass panel board.
There are 5 main materials that be used in producing Fibreglass panel board. Resin was one of the important material constituent in composites. There are two classes of resin which were thermoplastics and thermosets. Unsaturated polyester resin, as shown in figure, can be categorized as thermosetting resin which cure permanently by irreversible cross-linking at relevant temperatures were chosen in producing this product. Fiberglass are materials that combine with resin to strengthen the fabricated items. The thickness of the fiberglass mat is less than 1 mm. The type fiberglass used in this panel board is E-glass fiber, which are cheap and flexible. It is stronger than many metals by weight and can be molded into compact. Hardener is a concentrated liquid containing polyamine. This chemical liquid added in the unsaturated resin to cause a chemical hardening, or often referred to as hardener. Generally, the catalyst hardener mixture in the resin is about 1 till 2% calculated from the weight. Excess catalyst hardener in resin might cause rapid freezing and also depend on surrounding temperature. Next, yellow pigment was used also to increase the aesthetic value of the fiberglass panel board. Various colors can be chosen from the colorant or casting craft pigments that were designed to work with polyester resin. It designed to bond strongly to the polymer molecules that make up the textile. Lastly, mirror glaze were used in producing the fiberglass panel board. Mirror glass wax contains carnauba wax. It's created to make a barrier film that provided multiple releases with ultra-high gloss finished parts on the mold. There are 3 main processes in producing fiberglass panel board. Before the layering started, a mixture of resin were made. The necessary amount of yellow pigment were added into the resin and also catalyst hardener into the mixture. The first step is mirror glaze were wiped evenly on the mold to prevent the fiberglass to stick to the mold. After that, the fiberglass mats were arranged on the mold. Hand layering technique were chosen in producing the panel board. Mixture of resin was spread evenly with a brush on each of the layer. This is to ensure there are no air void on the layer during the layering process to prevent the structure of the panel board disturbed. Lastly, each of the layering process were repeated until the 13 layers, which to get the 10 mm thickness that required for the testings. There are 4 tests that have been carried out after the end result had finally been produced. The tests are water absorption test, swelling test, modulus of elasticity test, and modulus of rupture test. All the tests were compared with the conventional panel board. For the preparing panel for testing, the sample will be cut into area of 50 mm times 50 mm times 10 mm for water absorption and thickness swell test, while cutting the sample into the area of 240 mm times 50 mm times 10 mm for modulus of rupture MOR and modulus of elasticity MOE test.
The testing method is to determine the characteristic and the justification of the panel board. They have 4 types of testing such as modulus of elasticity, modulus of rupture, water absorption, and thickness swell test. The first one is modulus of elasticity that we know as MOE. Based on the graph of modulus of elasticity shown, there is a very huge difference between fiberglass panel board and standard panel board. The fiberglass panel board has the highest value of MOE, which is 8139.7 megapascal, compared to the standard panel board is 1921.8 megapascal. Higher value of MOE indicates that the fiberglass panel board has a higher stiffness compared to standard panel board with lower MOE value. Tensile properties of the composite are mostly affected by the material and method. The tensile strength of the composite depends to a large extent on the interfacial bonding strength between the metric reinforcement and also on the inherent properties of the composite ingredient. The second one is modulus of rupture MOR. There is a high difference between the fiberglass panel board and the standard panel board. The fiberglass panel board had a higher value of MOR, which is 187.3702 megapascal, than standard panel board, which is 23.9664 megapascal. MOR value is a measure of a specimen overall strength before it rupture. The fiberglass panel board is a typical composite material made of a plastic matrix that is reinforced by fine thin fibers, which has a high flexural modulus. Based on the microscopic point of view, the reinforcing fibers prevent crack propagation by chemically bonding to the polymer matrix with covalent bonds. Therefore, the higher value of the MOR indicate the more force required to it to break or rupture rather than the lower value. The panel board that had higher MOR value is better compared to the other one because it shows that the panel board can withstand higher force or load before it rupture. Next, we go to water absorption, WA. Based on the water absorption WA test result graph shown in the figure, there is an obvious difference between the fiberglass panel board and the standard panel board. The percentage of water absorption of fiberglass panel board is 0%, while the standard panel board is 112.5%. Water absorption value is expressed in percentage and it refers to property of absorbing water when panel board are exposed to or immersed in water. Higher value of water absorption indicate that the panel board has higher of water absorption rate and will absorb more volume of water compared to the panel board with lower value of WA. A lower water absorption value is better than a higher water absorption value because it shows that panel board is more waterproof, which is resistant to water when exposed to or immersed in water. Fiberglass panel board is water resistant because the polymeric plastic matrix consisting of polymerized monomer has the function of holding the fibers together in the composite structure. It also transfers stress between fibers and protects the fibers from the outside environment such as chemical, moisture, and mechanical shocks. The last one is thickness swell test (TS). From swelling test result, there is no changes in depth of the fiberglass panel board before and after immerse. Why? The standard panel board had changes on range 0.002 until 0.003 meter changes. The swelling test value is a measure of a specimen's depth changes before and after immerse. Therefore, the lower value indicate the less moisture that had been absorbed by the panel board. The panel board that had lower value of depth change is better compared to other one because it shows that the panel board can withstand the moisture content.